All right, we're back. We are on page 6 of notes 2 of Calc C, I guess. And we're talking about Taylor polynomials, and these are more than tangent lines, right? So a tangent line, the value of the function is the same, the value of the first derivative is the same. Taylor polynomial, you go beyond that. The value of the second derivative is the same, maybe the third derivative, up to the nth derivative for an nth degree polynomial. So that's what we're trying to do. And also maybe what I just said is, no, that's definitely true. Okay. So you often, when you're just doing these problems, you often don't know the function that you're trying to approximate. All that you really know about it are like values of the derivative. A weirder thing is sometimes you don't know the function. You don't actually explicitly know the values of the function, the derivatives, I should say, but instead you have a function that generates the derivative at the center. So this is weird. Let's take a look at these. So we have a function or a formula for the nth derivative at the center, right? So here in this problem we're going to do, we know that f of 3 is equal to 2, and then the nth derivative is equal to the quantity n minus 1 factorial over 2 to the n. Now that should probably say where n is greater than or equal to 1. A better question would say that. This is not a great question, and that's maybe okay. Or maybe it does work. 3, 2 over 2. No. Okay, so here I'm going to say that n is greater than or equal to 1. So that's like a common thing that you'll see, that greater than sign. There we go. Greater than, or I don't know. I'm trying my best, sort of. So let's try to write fourth degree Taylor polynomial. So it's sort of annoying to work these out the way that this is currently written. What does the nth term look like? So the nth term, I know for this particular problem is going to be the nth derivative at 3, x minus 3 to the n over n factorial, right? So in this case, that's going to be the nth derivative at 3 is this weird thing. So the quantity n minus 1 factorial, I'm going to kind of simplify it, x minus 3 to the n over. So n minus 1 factorial over 2 to the n, and then times n factorial. But n factorial can be rewritten, trying to find a different color. This is the same as n times the quantity n minus 1 factorial. And then the n minus 1 factorials can cancel. So this is really just x minus 3 to the n over 2 to the n times n. That's the nth term, right? So what I'm going to do, this is where n is greater than or equal to 1, according to our work. So why doesn't the 0th derivative need to fit this pattern? Well, the 0th derivative doesn't need to fit this pattern because what we could do is, no matter what, we could take the function that we're approximating and vertically shift it. You just shift it up 2, shift up 10, whatever. So the actual value of the function is the only one. It just doesn't need to fit the pattern. So we have this pattern. It only applies to the derivatives, not to the original. But we have to remember the original when we write our polynomial. So I'm going to call it p of x, I guess. And it's going to be 2, the value of the function. And now we are into our nth terms, right? So when n is equal to 1, so I'm looking over here. When n is equal to 1, we're going to get plus the quantity x minus, what? X minus 3 to the first over 2 to the first times 1. And then we're going to get plus the quantity x minus 3 squared over 2 squared times 2, plus the quantity x minus 3 cubed over 2 cubed times 3. And then finally, because we want 4th degree, we'll go quantity x minus 3 to the 4th over 2 to the 4th times 4. That's our polynomial. That's an approximation of the function that satisfies this given information. And so we don't know what the function is. We don't know how good an approximation we will have made yet. We might at some point be able to figure that out, but that's what we're going to go with. So let's see if we can do this. So here, do we want to, I don't know if we want, well, all right, I'm going to write out. So again, it's possible that the 0th derivative, the original function, doesn't fit this pattern. And it definitely does not, right? If n is 0 and you plug in here, you do not get 3. But you don't need to, because a vertical shift would change what you would have gotten. So that's the reason that doesn't need to fit. I'm going to write out what I think the nth term looks like, just so I can like maybe go more quickly. I also might not be able to, but I find it's a little, I make fewer mistakes. So it's going to be this. So x plus 1 to the n over, that's not an n, over n factorial. That's what my brain made, a sideways n. A 2 looks a lot like a sideways n. I don't know, like try it out. So let's see. 5th degree. So we're going to say p of x. Start with the value of the function, which is 3. Now we're going to let n equal 1, which gives me -1 to the first is minus x plus 1 to the first over 4 to the first times 1 factorial. And then we're going to let n be 2. So -1 squared is +1, then x plus 1 squared. So just like factorials, you don't typically expand exponents. So I'm just going to write 4 squared and then 2 factorial. And minus x plus 1 cubed, 4 cubed, 3 factorial. So like once you see the pattern, just go with it. It's like less work to see the pattern and kind of adapt to it than it is to like keep going back and actually thinking about something in. Plus 1 to the 5th, 4 to the 5th, 5 factorial. This is our polynomial. It is 5th degree. Ask an algebra 2 student, they'll be like, yeah, it's 5th degree. I mean, they'll probably freak out because it's a weird looking 5th degree polynomial, but it's 5th degree. We got the center correct, right? That's where our +1s are coming from. Don't forget the center. And it worked. All right, let's try another one. So here, again, it's our derivative for n greater than or equal to 1. I should really go back and edit the notes and put that in, but like these notes are a disaster as far as like formatting goes. So like as soon as I change one thing, it's like everything's in these tables and it's going to change everything. So I'm really hesitant to do that, even though it would make it better. I don't know. I guess like time will tell. And if you're looking at notes that have that, then like good job to me. If you're not, then like I'm not really surprised. All right, here we go. Should I write down the nth derivative again, or the nth term? I think so. I don't actually usually do that. Well, sometimes I do. I don't know what I'm saying. It's going to be the n plus 1. So this guy's staying in the numerator this time. And x minus pi to the n over n factorial. So like nothing's going to simplify. So don't forget your minus pi's, right? It's got to be at the center. And you can tell, like if this hadn't been at pi, then we'd kind of be stuck because we only know information at pi. So p of x going to be the value of the function, which is just -3. And now we're into like nth term mode, right? So when n is 1, we're going to get -1 squared. So that's plus 2 to the 1/2, which is square root of 2, but I think 2 to the 1/2 is probably better. Pi to the first, 1 factorial. And then when n is equal to 2, we get -1 cubed, which is minus. Get 2 to the 2/2. I'm going to write 2/2 because I'm a big fan of keeping the pattern obvious, and I think that helps. And then when n is equal to 3, we get -1 to the 4th, so plus, what are we doing here? Okay, 4th degree, 2 to the 3/2, x minus pi cubed, 3 factorial, and then minus 2 to the, I'm going to say 4/2, x minus pi to the 4th over 4 factorial, and there we go. We don't know the function, but we got the center right. We matched each of the derivatives according to this weird function that we were given, and so it's working. Should we check that on the calculator? Maybe. Do I want to type that is really the question. I mean, I definitely don't want to. Maybe I can do something weird. Let's try this. Let's see. So, I mean, if you're done, you're done. You know, head on out. Do what you got to do. I'm gonna play around for a second here. I'm gonna see if I can write p of x in like a weird way. So I'm gonna write p of x is -3 plus. I'm gonna try to write a summation, right? So I want to do the summation from I'm gonna say n is equal to 1 up to 3. I think this is working, but it's gonna be -1 to the n plus 1. And then 2 to the n over 2. And then we need an x minus pi to the n over n factorial. I don't know what this is going to do with anything, but I think this is our polynomial that we wrote. So like if I do p of, so it's at the center that the things are the same. So p of pi gives me what I want. So if I do the derivatives, what am I expecting here? I'm expecting, so if I do the derivative of p of x when x is equal to pi, I never really worked this out, but it should be 2 to the 1/2 because of the polynomial that I'm looking, and it is. So if I do the, let me just type it, derivative p of x, x is the variable, second derivative at x equals pi, I feel that that should be -2. And it is. Let's try the third derivative. So the third derivative, I think, should be 2 to the positive 2 to the 3/2. But 2 root 2 is the same as that. The fourth derivative should be -4, -2 squared, which is, whoops, fourth derivative. Why are you giving me the fourth derivative? I didn't do enough terms. I got to do 0 to 4. Not 0 to 4, 1 to 4. Why do I need that? Because the because the 0th is the, fourth degree. What I wrote doesn't go up to the fourth degree, right? Like I only did up to the third, and so then the fourth derivative would have been 0, so that makes sense. Now it should give me -2 squared, -2 squared, -4. I don't remember what I even said because I got so flustered when it didn't work. So this is working. I don't know, you know, not great, but working. Let's take a look. Let me just explain briefly where I got those values of the derivative. So I knew that the original function should give me -3. Then I knew that the first derivative should just be this, where this sign goes with it. So I knew it would be that. Then the next one, I knew that this sign would go with it. So it'd be -2. Then the next, so this is why the form is really important. You got to get it so it looks exactly right. So I knew this would be positive, whatever. And then here I knew it would be -2 squared. So I knew it would be -4. So I'm looking, because it should be the nth derivative, x minus a to the n over n factorial. You should be able to find the nth derivatives just by looking at this form. And it's all about pattern recognition, which, like, everyone who makes it to this level is usually really good at recognizing patterns. So I'm going to cut this here, and I'll be back in the next video to do some more. So I will see you there.